the previous year level, you have learned about linear equations and how to find their solutions. You were also given some applications to solve some real problems using this concept. Now, since you are in a new grade level, you will acquire knowledge and skills about quadratic equations. In this video lesson, you will learn different ways to illustrate quadratic equation, and it will be helpful to understand the succeeding topics. For our learning target, at the end of this learning session, you should be able to illustrate quadratic equations. Let us recall how to multiply polynomials. Remember that to multiply two polynomials, multiply each term of one polynomial by each term of the other polynomial. Then, simplify by combining similar terms if needed. Let's have an example. Number 1. X times the quantity of x plus 5. Since we are multiplying a monomial into a binomial, we just simply use the distributive property. That is, distribute the monomial to the binomial. That is, x times x is x squared. X times positive 5 is positive 5x. Therefore, the product of x times x plus 5 is equal to x squared plus 5x. Let's consider example number 2. The quantity x plus 3 times the quantity of x minus 2. We are multiplying a binomial into a binomial. First, you're going to copy the first term of the binomial. We have x times the second binomial, which is x minus 2. Then copy the second term of the binomial, that is 3, and multiply it to the second binomial, that is x minus 2. Then simplify applying your distributive property. That is, x times x is x squared. X times negative 2 is negative 2x. Then 3 times x is positive 3x. 3 times negative 2 is negative 6. Then combine similar terms. Copy x squared. Negative 2x plus 3x is x. Then copy negative 6. Therefore, the product of the quantity x plus 3 times the quantity x minus 2 is x squared plus x minus 6. Now, it's your turn. Let us answer the following activity. Multiply and simplify if needed. Number 1. X times the quantity of 2x minus 7. You have 5 seconds to answer that. Your time starts now. Okay. Let's simplify. We are going to multiply the monomial to each term of the binomial, applying the distributive. We have x times 2x is 2x squared. X times negative 7 is negative 7x. Did you get the same answer? Very good! Number 2. The quantity of x plus 5 times the quantity of x plus 9. Your time starts now. Okay, to get the product, you copy the first term of the binomial and multiply to the second binomial, that is x plus 9. Then copy the second term of the first binomial, which is 5, and multiply to the second binomial, that is x plus 9. Then apply the distributive property. That is, x times x is x squared. X times positive 9 is positive 9x. 5 times x is positive 5x. 5 times 9 is positive 45. Then, combine similar terms. That is, copy x squared, 9x plus 5x is equal to 14x, then copy 45. Therefore, the product of x plus 5 times x plus 9 is x squared plus 14x plus 45. Did you get the same answer? Very good! For number 3, we have the quantity of 2x minus 1 times the quantity of x plus 3. You have 5 seconds to answer that. Your time starts now. First, you copy the first term of the first binomial, that is 2x, and multiply to the second binomial, that is x plus 3. Then, copy the second term of the binomial, which is negative 1, and multiply it to the second binomial, which is x plus 3. Then, you are going to simplify. Applying your distributive property, we have 2x times x is 2x squared, 2x times 3 is positive 6x, negative 1 times x is negative x, negative 1 times positive 3 is negative 3. Then combine similar terms. Copy 2x squared, 6x minus x is positive 5x, then copy negative 3. Did you get the same answer? Excellent! For number 4, we have the quantity of x plus 6 raised to 2. You have 5 seconds to answer that. To get the product of that, squaring a binomial, the first thing that you are going to do is to square the first term, and to get the middle term, twice the product of the first term and the second term, and to get the last term, square the last term of the binomial. Our first term is x, then our first term is x, and our second term is 6, and the last term or the second term of the binomial is 6. Then simplify. That is, the square of x is x squared. 2 times x is 2x times 6 is positive 12x. 6 raised to 2 is 36. Therefore, the product of x plus 6 raised to 2 is equal to x squared plus 12x plus 36. Did you get the same answer? Very good! For number 5, we have the quantity of 5x plus 4 times the quantity of 5x minus 4. So you will have 5 seconds to answer that. As you can observe, we are multiplying a sum and a difference of a binomial. In simplifying, we need to square the first term minus the square of the second term. The first term is 5x and the second term is 4. Simplify. Square of 5x is 25x squared minus square of 4 is 16. Did you get the same answer? Very good! For number 6, we have the quantity of 3x minus 8 times the quantity of x plus 2. You have 5 seconds to answer that. First, you copy the first term of the first binomial, which is 3x, then multiply to the second binomial, which is x plus 2. Then, copy the second term of the first binomial, which is negative 8, multiply it to the second binomial, which is x plus 2. Simplify it. Applying your distributive property, we have 3x times x is 3x squared. 3x times positive 2 is positive 6x. Negative 8 times x is negative 8x. Negative 8 times positive 2 is negative 16. Then, combine similar terms. Copy 3x squared. 6x minus 8x is negative 2x. Then copy negative 16. Now, let's take a look of all the answers of the activity. How will you describe the products obtained? Very good! They are all polynomials. What is the degree of each product? Excellent! They are all polynomials of degree 2. There are situations that represent other function that is equally important as linear function. Let's consider this problem. In the middle of a crisis where establishments are closed and prime commodities are hard to find, we think of having our own vegetable garden. This way, we can get our supplies of vegetable right in our own backyard. Aling Tuding is a resourceful person. That is why she is planning to convert her rectangular vacant lot at the back of her house into a vegetable garden. She remembered that the area of her vacant lot is 15 square meter. She also recalled that the length is 3 meters longer than the width. Without even starting to cultivate the soil, Aling Tuding is already excited to harvest her favorite vegetable soon. What equation would represent the attributes of the rectangular garden? Do you think you can use the equation to find the dimensions of the rectangular garden? Why or why not? Despite of the crisis, we should be like Aling Tuding. We must make this crisis an opportunity to develop and strengthen ourselves. Let's investigate the measurement of Aling Tuding's vegetable garden. First, let us identify and represent the unknowns in the problem. If we let x be the width of the garden, x plus 3 the length of the garden, because it states here that the length is 3 meters longer than the width. And the area of the garden is 15 square meter. Let us illustrate the problem. So we have a rectangular garden whose area is 15 square meter, and width, that is, we represent it as x, and the length of the rectangular garden is x plus 3. Take note that in computing the area of a rectangle, we use the formula A is equal to length times the width. Substitute the given into the formula. The area is 15 and the length is x plus 3 and its width is x. Simplify the equation, we have 15 is equal to, distribute the monomial to the binomial, that is x times x is x squared. X times positive 3 is positive 3x. Then write that in a standard form, we have x squared plus 3x. Applying addition property of equality, add both sides by negative 15. That is, negative 15 is equal to 0. The equation in one variable obtained from the situation x squared plus 3x minus 15 is equal to 0 has a degree 2. It means that the highest exponent of the variable is 2. This kind of second degree equation is what we call quadratic equation. Now, let's define quadratic equations in one variable. A quadratic equation in one variable is a mathematical sentence of degree 2 that can be written in the form ax squared plus bx plus c is equal to 0, where a, b, and c are real numbers and a must not be equal to 0. Take note that your a must not be equal to 0. What will happen if a is equal to 0? Very good. It will become a linear term. So, a must not be equal to 0. In ax squared plus bx plus c is equal to 0, ax squared is what we call the quadratic term, bx is what we call the linear term, and c is what we call the constant term. In addition, a in the quadratic term is the coefficient of x squared, which may be positive or negative but not equal to 0. B in the linear term is the coefficient of x, which may be positive, negative, or 0. C is the constant term, which may be positive, negative, or 0. Going back to our equation, x squared plus 3x minus 15 is equal to 0, since it is written in standard form, we can easily identify the values of a, b, and c. Look at the table to understand it better. The quadratic equation in standard form is ax squared plus bx plus c is equal to 0. Its quadratic term is ax squared. Its linear term is bx. Its constant term is c. Now, from the given equation, x squared plus 3x minus 15 is equal to 0, the quadratic term is x squared. The linear term is positive 3x, and the constant term is negative 15. Therefore, the value of a is the numerical coefficient of x squared, that is equal to 1. And the coefficient of x is 3, then the value of b is 3. And the constant term is negative 15, therefore the value of c is negative 15. Now, let's consider the following example. Determine if the given equation is quadratic. If yes, identify the values of a, b, and c. For letter A, we have 3x squared plus 2x is equal to 9. You have 5 seconds to answer. Time up. The correct answer is quadratic. To identify the values of a, b, and c, we must transform 3x squared plus 2x is equal to 9 into its standard form. Take note that the standard form of quadratic equation is in the form ax squared plus bx plus c is equal to 0. So copy 3x squared plus 2x. Applying the addition property of equality, add both sides by negative 9. That is negative 9 is equal to 0. Then it is already in the standard form. The value of your a is the numerical coefficient of the quadratic term, which is 3. And the value of b is the numerical coefficient of the linear term, which is 2. And the value of c is the constant term, which is negative 9. Let's consider example letter B. The quantity of x minus 5 times the quantity of 2x plus 3 is equal to 7. You have 10 seconds to answer that. To check if the equation is quadratic, multiply the left side of the equation and simplify by combining similar terms. That is, x times 2x plus 3 minus 5 times 2x plus 3 is equal to 7. Distribute the monomial to the polynomial. We have x times 2x is 2x squared. X times positive 3 is positive 3x. Negative 5 times 2x is negative 10x. Negative 5 times positive 3 is negative 15 is equal to 7. Then combine similar terms. Copy 2x squared. 3x minus 10x is equal to negative 7x minus 15. Applying the addition property of equality, add both sides by negative 7 is equal to 0. Combining similar terms, copy 2x squared minus 7x. Negative 15 minus 7 is negative 22 is equal to 0. Since the degree of the equation is 2, it is a quadratic equation. The value of A is 2. The value of B is negative 7. And the value of C is negative 22. Now, let's consider this example. 2x squared minus 15 is equal to 2 times the quantity of x squared plus 7x. You have 10 seconds to answer that problem. To check if the equation is quadratic, simplify the right side of the equation, then combine similar terms. Copy 2x squared minus 15 is equal to 2 times x squared is 2x squared. 2 times 7x is positive 14x. Then combine similar terms. That is 2x squared minus 2x squared minus 14x minus 15 is equal to 0. Simplify, we have to cancel 2x squared minus 2x squared because that is equal to 0. Then copy negative 14x minus 15 is equal to 0. Since the resulting equation has a degree of 1, then it is not a quadratic. Thus, negative 14x minus 15 is equal to 0 is a linear equation. Let's have another example. Represent each situation using quadratic equation. A rectangular prism has a height of 3 meters. Its length is 3 times its width. The volume of the prism is 18 cubic meter. First, the given is a rectangular prism. Its height is 3 meters. The volume is 18 cubic meter. Then after identifying the given, we are going to represent the unknown. Let W be the width and 3W be the length, since the length is 3 times the width stated into the problem. And the formula that we are going to use in computing the volume of a rectangular prism is length times the width times the height. Substituting the values of the variable from the given, its volume is 18 cubic meter is equal to the length is 3W times the width times the height, which is 3. Simplify it further. Copy 18 is equal to 3W times W times 3 is equal to 9W squared. Write that in standard form, we have 9W squared minus 18 is equal to 0. Thus, the quadratic equation that represents the situation is 9W squared minus 18 is equal to 0. Let's have another example. Jody is constructing a model house. He wants its window to have an area of 315 square centimeter, and he wants the length of each window to be 6 centimeter more than the width. First, identify what are the given. The area of the rectangular window is 315 square centimeter. Then, we are going to represent what is the unknown. Let x be the given width and x plus 6 be the length, because it's stated into the problem that the length of each window to be 6 centimeter more than the width. And in computing the area of a rectangular window, we use this formula. Area is equal to length times the width. Substitute the values from the given into the formula. The area is 315 is equal to the given width is x times the given length is x plus 6. Simplify that, we have x times x is x squared. X times 6 is positive 6x. Minus 315 is equal to 0. Thus, the quadratic equation that describes the situation is x squared plus 6x minus 315 is equal to 0. Let's have another example. The product of two numbers is 48 and their sum is 16. Represent that situation using quadratic equation. First, identify what are the given. The given are the product of two numbers is 48. The sum of two numbers is 16. Then represent the unknown. Let x be the first unknown number. Let 16 minus x be the second unknown number. It says in the given that the product of two numbers is 48. So we have first number times the second number is equal to 48. Our first number is x times the second number, which is 16 minus x, is equal to 48. Simplify. X times 16 is 16x. X times negative x is negative x squared is equal to 48. Then write that in a standard form. We have negative x squared plus 16x minus 48 is equal to 0. Therefore, the quadratic equation of the described numbers is negative x squared plus 16x minus 48 is equal to 0. Let's have another example. The product of two consecutive even integers is 288. First, identify what are the given. numbers are two consecutive even numbers. Product of the two numbers is 280. Represent the unknown. Let x be the first number and x plus 2 be the second even number. It states that the product of the first number and the second number is 288. So we have first number times second number is equal to 288. Our first number is x and our second number is x plus 2 is equal to 288. Simplify. X times x is x squared. X times 2 is equal to 2x is equal to 288. Write that in standard form. We have x squared plus 2x minus 288 is equal to 0. Therefore, the quadratic equation for the described numbers is x squared plus 2x minus 288 is equal to 0. That's it. Thank you for watching. We will continue discussing in the next series of episode more topics about quadratic equations.